Hello and welcome to another one of D's ADD videos. Today we're going to be looking at some examples of determining convergence and divergence for a sequence. If you remember the rule, it was as follows. If you take the limit and you get a number, it converges. If you get plus or minus infinity, it diverges. That means that the area is just infinite under the curve, or actually under the points, and therefore would not be finite and diverge, whereas the converges are finite and can be summed up. So let's look at this in action. Let's take the limit of the first one. Let's do it in red. And when you plug in, you're going to get infinity over infinity, which is indeterminate, which means you can't figure it out the way it sits. In this case, it'd probably be easier to do L'Hopital's rule. And that would give you the derivative of the top would be 2n, and then the bottom would be 1 minus 3n squared, which is still infinity over infinity. That's still indeterminate, so let's do it one more time. You're going to get 2 over negative 6n, and when you plug in your infinity, in this case you're going to get 2 over negative 6 times infinity, which is a negative infinite. Any finite number over infinite always equals 0. So because we got a 0 there, we would say, therefore, don't ask me how mathematicians got together and said 3 dots in a triangle. That means therefore. The sequence converges because we got a finite number. We didn't get infinity, we didn't get negative infinity. Okay, I think I went a little bit too far to the right on that one. Let's see if I can squeeze this other one here. Actually, let's go ahead and do it the algebraic way too, just to compare notes. I'll do that in green here. If I did it the other way, I would have factored out the common n squared to the top and bottom. That would have left me with a 1 over n minus n. And that's just doing what you had originally. N over n squared gives me that term. And then n cubed over n squared, hat over factor. Then the n squareds cancel. I get 1 over n minus n. This one here goes to 0 when I plug in infinity. And then I'm left with 1 over n, which when I replug in infinity gives me 0. So either way, we're going to get that it converges. Alright, let's look at the next one. I'm going to go ahead and do it the algebraic way. It seems a little bit faster, especially with these large exponents. In this case, we're going to have infinity over infinity. So again, it's indeterminate. So in this case, we factor out the common n squared, and we're left with n squared plus 2 over n plus 1 over. Well, actually, I lied. 2 over n cubed plus 1 over n to the 4th. Over n squared 1 plus 2 over n squared. The n squareds then cancel, and all of these terms with n's in the denominator, because we're going to infinity, are going to go to 0. As the bottom gets really large, overall we start getting smaller. And then we're just left with the n squared expression, and that n squared, when you plug in infinity to it, gives you infinite. Therefore diverges. Okay. And finally, the last one is just to see if you remember your trig. once in a while I'll just pop something on you just to see. Let me move this over to the right. So that problem was a sub n equals arctangent of n. And first step is to take the limit as n approaches infinity of arctangent. And if you remember the graph of arctangent, most of you probably don't, it looks like this and has asymptotes here and here. This is y equals pi over 2, y equals negative pi over 2. And the graph does something like this here, and it gets closer and closer to the two asymptotes. So if I'm approaching positive infinity for x, y would be approaching this line right here, this green dashed line, so that would be pi over 2. Well, that's a finite number, so therefore converges. Okay? So practice these. They're not too bad, as you can see. You just have to know the rules, and just if it equals a number, it's convergent, and if it equals a infinite value, it diverges. Okay? I've clarified things for you. Practice, practice, practice. Thank you, and have a nice day.